Welcome back to the lab, folks. We have a package in from PCBWay, and it is indeed the boards for our little VCO project. Here we go. Nice looking boards. I really like the white solder mask. Yeah, it looks smart. You can really tell the components. It's very legible. You can read everything nicely, and it's nice and bright. All right, now looking at these. These are, let me show you what these are. These are patterns to use with these little hoops here for making connections using alligator clips or those little grippers. But I think I made them too close together. I think I'm going to have to make them further apart in the future. It looks like it's going to be difficult to get alligator clips in there. So I would say twice that spacing would probably be ideal. But anyway, I'm dying to get these up and running. So why don't I collect all the parts and get set up to start putting one of these or two of these together. And yeah, let's get on to that right away. All right, got enough components assembled here. I got my tools already. My iron is on and hot. And yeah, it's nothing like soldering. It's so therapeutic. It's so therapeutic. I love it. Gives me a chance to think, to mellow out for a little while. All right, let's get started. All right, we've got two boards made up. The difference between these two, I need to put a jumper on this. The difference between these two is that this one I've put the capacitors on the output to remove any DC offset. And this one I've just gone straight through, just wired the capacitors out so we can have the output with the DC offset, so we can have a look at that too. And that might be handy for certain applications. Okay, let's put the jumper on this one. Okay, we'll jumper the same as the other one. This would jumper in the low frequency range for both of these. So let's get them hooked up to some power and look at them on the scope, and we'll be right back. Okay, so we've got the one with the directly coupled output is all hooked up to power. We've got a variable resistor going from VCC to ground, and then the center pin of the variable resistor is coming out to the control voltage. We have a control voltage coming in of 1 volt. And we have coming out of it a nice square wave with about 73 hertz there. Let's go over and look at the triangle waveform. So there's the triangle waveform. You can see it's displaced up about halfway. And you can see that the peak-to-peak voltage here is 10 volts. Rise time about 9 microseconds. Powering this operational amplifier right now at 12 volts. Okay, everything is as expected. Looks like I didn't screw up picking the board. And now the peak-to-peak range on this here is 4 volts. Let's go back over here to the square wave. And I'm going to increase the voltage here to 2 volts because I want to see how linear this thing is. So we'll see if the frequency doubles as well. So we'll bring this up to 2 volts here. And we have 146. So that is twice the frequency, twice the voltage. Nice and linear. Let's bring it up to 4 volts and see if we get 292 hertz. 289. So that's not too bad. Let's bring it up to 8 volts. So we should expect something like just below 600 hertz here. And we've got 567. So the linearity suffers a little bit as we go up. Of course, that can all be compensated for. Rise time, of course, is still 9.3 microseconds. We're still fairly flat at 10.8 volts peak to peak. The voltage range should be close to twice the supply voltage. Yeah, I think it's 2 times VCC minus 3. So let me see if I can arrange for that. Okay, so now I've got 19 volts going into it, and it looks like our frequency here is up to 1.28 kilohertz. So we'll bring that down to, what's half of 19 is 9.5, so we'll bring that down to 9.5. So it is pretty linear. Now you can go all the way down here to, frequency gets pretty low. We're on the low range here, so we can expect that. We get right down to, let's bring it down to half a volt, 1/10 of a volt. We're down to 6 hertz. Okay, so it drops out there, comes back in there. So we get down to about, let's say 1/10 of a volt. And at that, we've got about 4 hertz coming out of it. Now we stick this on the high range. That's using the small capacitor. So that, the low range was the 10 nanofarad capacitor. The high range is the 220 picofarad capacitor. Okay, we've got 175 hertz. Let's see if we can get it drop out the same place. There we go. We can get down to 0.04 volts, in which case we got 43 hertz. And we can bring that now. Let's bring that up to a full 19 volts here. Let's see how high the frequency can go here. Not looking much like a square wave anymore. I think that's mostly due to that 9.5 microsecond rise time. But so we're up at about 15.5 kilohertz. We got pretty good range with these. Okay, so it's working out pretty good. So now we can actually control this with a voltage. We can get our frequency dependent upon a voltage, and it's nice and linear. I think the next thing I want to do is I want to hook this up. Let me hook this up a different way. I'll be right back. Okay, that took a few minutes, but it was an enjoyable few minutes because I got to practice one of my other little hobbies, playing around with my computers. Now I do have a computer like this. This is my bench computer. It's a little plug-in module, which is the actual processing unit, and a little backplane. I can plug cards into it, and I can control experiments on the bench. And so I wrote a little program here to kind of demonstrate the use of this as a synthesizer. Now again, you have to take into consideration I've only configured this for 256 different voltage levels. So what you're going to hear may not be in perfect pitch, but it's definitely a good demonstration of what I'm talking about. And the first thing it'll do is it'll play a scale, a 2-octave scale from C2, I think C2 to C4. And then it'll play a little melody. I hope it's out of tune enough that I won't get a copyright strike on it. It's a very short little bit of a melody. And then it'll go into just playing a random sequence of notes. Yeah, it's a good demonstration, I think. You can see all the changes in frequency coming up on the scope as well. Here we go. There we have it. So I don't think I'll get a copyright strike on that. I paid for a copy of the music, and this is definitely my own personal performance of that music. So I think I should be safe on that. I'm going to try and set it up for another demonstration. I mentioned earlier about feeding one into the other. So we're going to do that and see what we can get happening when we do that. Okay, let me set up for that. I'll be right back. Okay, you can see up there in the scope, before I turn the sound off, you can see up there in the scope, what we're doing is we're taking the triangle output of this one here, and we're using that as the control voltage for this one here, and we're looking at the square wave coming out of that. So you can see we've got some frequency modulation going on here. So let's have a listen to what that sounds like. Now this sort of thing is to be kind of expected. So, but once you start getting, once the frequency of the driving oscillator starts getting up close to the frequency of the driven oscillator, you get some very interesting effects. There's your alien ray gun noise. Let me get another scope channel on this and we'll have a look and see what's happening here. Okay, you can see there the bottom trace, the blue trace is the modulation trace. So you can see as we start getting up in frequency there, you can get some really neat effects. Now, of course, the modulation frequency is the dominant frequency here now, so we're not going to hear much of the modulated frequency anymore. All right, guys. All just for fun. It's a very fun, interesting little project. I'm half tempted, to put together another synthesizer, but to tell you the truth, oh boy, it took a while. Like building a synthesizer is not an easy task. It took, I think, most of my third year at college to build that synthesizer to a point where it was working. But you could do some pretty amazing things, like especially taking a keyboard as input to one of the oscillators, produce your melodies, and then you can have counter melodies being produced by the computer, and then you can have all sorts of interesting effects with low frequency oscillators modulating some of the tones, changing the ADSR as you go along. There's all sorts of interesting things you can do. If you've ever been interested in synthesizers, especially the old classic synthesizers like the old Moogs and the ARP, what was it, at the ARP 2006 or something? I've forgotten the name of it. But my father was a manager of a film post-production studio, and they had one of these ARP synthesizers in there, and I used to spend weekends in there playing with it for the longest time. But basically, it's a whole bunch of voltage-controlled oscillators, ADSR units, voltage-controlled amplifiers, noise, and all that sort of thing that you can knit together in any way you want, and you can get the most amazing effects. So that's it. Here's a little VCO circuit. This was a lot of fun for me. I hope you guys try, build one up, play around with it. I mean, there's an endless source of fun, especially if you have a little bench computer that you can attach it up to. You can do all sorts of amazing things. Thanks again, PCBWay, for making this possible. And we'll see you in the next video, guys. Bye-bye.